because he was colorblind, only has the colorblind allele to pass on to you. So you are not colorblind, so your mom was homozygous dominant, which means you are a carrier of that colorblindness gene. So off the top of your head, can anybody tell me what are the chances of her having a son who's colorblind? 50%. You have a 50% chance of having a son that is colorblind. It is what it is, but it's a kind of a cool thing when you look at all these situations genetically and you can go, big picture-wise, general things, this is one of those kind of cool things that I can figure out and we can use Marcella as an example of, here's kind of a, I mean, it's not an awesome thing, but it's like you can literally look back and go, oh, this is my chances, and that's what they use this. Same thing with the blood typing. There are some situations where the mom's blood type could kind of interfere with the baby a little bit, okay? Let's keep going a little bit so we don't fall behind. So watch. So if we have, what are the two possible genotypes for somebody who has B blood? BB. Here, let me bring this up a little bit. Okay, so we're going to do BB. If you're following along, we're doing this okay. I don't care. We'll do it like this. So BB and BO. If you're O blood, what's the only genotype you can have? OO. So if you do all the possible combinations, what are the possible genotypes for the kids? BO and OO are the only types. So what are the possible phenotypic blood types for the kids? You can only have B and O. And what's the only blood types the kids could not have? A and AB. Okay, if you happen to get this and you're like, I got this, and you want to move on, go for it. Otherwise, I know this can be a little confusing. Look at the A one. What are the two possible genotypes for the A? AA and AO. Make sure you're filling out too if we were doing this together. What about B? BB and BO. So this is another one where you have to try and figure it out. You can do this one and this one is what? This one, this one? This one, this one? You got, what are all the possible combinations we have? We have AB, what else? AO, what else? BO, what else? And you can have OO. So what are the possible phenotypes for the kids? AB, help me out. A, what else? O, what else? So what blood types could the kids not have? Those are genotypes. This is one of those situations where you couldn't figure out, if there was a weird mix-up and they had two babies mix up or something weird, they couldn't narrow down which baby would belong to which parents, because this is why the blood typing really isn't any good for confirming if you belong to somebody or you're the parent of a kid. It's more of it's better for discounting you and saying you not belong to those parents. Okay, you want more or not? Okay, so AB is the first one only. What about the next one? AA and AO. So the genotypes of the kids could be what? So we got A. Well, we got AB. No, not AB. Yeah, AB. Correct. Sorry. Hang on. AB. What else? AA. AO. And BO. So what are the possible blood types for the kids? A, B, and what could the kids not have? They couldn't have O. Okay, and the next one's going to be similar to that one as well because you have the same basic setup. AB again is for dad. Mom's going to be BB or BO. Blood types, I'm sorry, genotypes of the kids? AB could be. AO. BB. So what are the blood types of the kids? Are we all doing this or not? A, B, and what else? A, B. Okay, what could the kids not have? Yeah. All right, so some of these get a little bit easier because if you have, like, mom has O type blood, her only genotype is OO. What about AB? AB is all you can have. So this is a weird one. I like this one. What are the possible genotypes for the kids? AO or? So what are the blood types of the kids going to be? A or B. So so what could the kids not have? So the same thing that the parents had, the kids can't have. So not that it's like, oh, earth shaking, but it's like, oh, okay, that's kind of a cool thing. You don't really notice that and see how that works. The last one's the easiest one. OO and that's it. What are the kids going to have to be? And O type blood, right? So they can't have AB or B or A. Make sense? Go to the next page. Let me show you something. I can stop and let you do this on your own if you want.
No, thank you.
I think this is one of those activities. It's pretty easy, but it just takes a little bit of push over the edge to go for your understanding. Okay. Now watch. And because of where we are at the semester, time-wise, we're pushing a little bit. Watch. Mr. Smith has type A blood. Miss Smith has type O blood. So we can set it up like this. This is one where you're going to have to do some Punnett square action or reverse Punnett squares. Let's go ahead and do Dad. Make a little label. What's Dad's possible genotypes? AA or AO. What's Mom have to be? OO. So I'm going to set up two Punnett squares real quick if I'm going to do this to say, because the question says, can you prove that a child with blood type A is theirs? Why or why not? Show your work. So I'm going to show two Punnett squares. I'm going to put, the only one that's going to change is going to be Dad's genotypes. So I'll put, this one's going to be an AA, where Mom's going to be OO, if that's Dad's actual genotype. However, if Dad has the AO genotype, we'll account for that scenario. So we'll do, this one's going to be all what? AO, right? And the baby has type A blood, right? So that would could you say that those parents are probably his parents?
Yeah.
Now watch, what if you did this one? AO, or? So with this scenario, could you prove that the kid was theirs?
No.
You can't prove because there is a possibility could be O. Right? There's a possibility on it. So let's switch it up again. Go to number 2. There's a baby mix up at the hospital, the Smith's baby and the Gonzalez's baby. One baby has type O blood. So what's the genotype? OO. So we're going to do 1 equals OO. And the other baby, number 2, has what type of blood? Okay, so it could be what? BB or? Use the Smith's genotypes from question 1 to help you answer the question. Can you figure out which baby belongs to who? Who belongs to, which baby number belongs to the Smiths? Baby 1, why? Why could they not have baby 2? There's no B alleles. The Smiths have no B alleles, so it can't be theirs. So you can do some wording, you can do some Punnett squares, but that's pretty basic. However, go to number 3. Would you be able to solve the mix-up? So get rid of the Smiths altogether. No Smiths. So we're just going to look at this. If the Gonzalez's blood types were A and B, what we'll say Dad is A. So what are the two genotypes? Mom is B type. What are the two genotypes? Now I'm going to save us some trouble. And this is one that it's amazing for me for a teacher to watch and see how much people pay attention. About 10% of the people get it. They'll do all the possible crosses on this, except we already kind of did this. Go to the front page. Go to that third one down where it's A and B. The parents are A and B. Could you sort out which kid was which if you only have the Gonzalez's blood type? Why? They could have any type of blood type for those kids. They can have any type of blood type for those kids. There's none that they could not have. Okay? Make sense?
Yeah.
Okay, go back to the other side. Now we're going to flip it and we're going to reverse this a little bit. It's just some thinking stuff. You're still, when it comes down to this portion of the test, that's why I'm giving you this now and making sure you're real clear on it. This is that essay question, the 25% of the test is this. Okay? Because if you can do this, you can do all codominant ones, you can do all normal dominants, everything like that. Watch this one. It says, in each of the following problems, you're given the outcome of the parental crosses. So you're going to have to go backwards. All the children are AB, so I'm going to set up a Punnett square. I'm going to put AB in all the squares because that's what all the kids came out with, they said. Now from this, we'll figure out what were the parents. To get an A here and an A here, what has to be here? If you have an A here and A here, what has to be here? Okay. You could set this up different ways. You could have AA on that side, and if you have a B here and a B here, what has to be here? B. And what has to be here? B. So the parental genotypes are AA and BB. You could have said that they were switched. Doesn't really matter. You could have said, how did I get B here and B here? Put a B here. Well, then you would have had to have an A on this side. Doesn't really matter, but I wanted you to get the point. Let's switch it up one more time. I know I didn't leave enough room to write on here, but the children are half AB, half A. Watch. I can put them anywhere. I'm going to put the two ABs right here. Now watch. A could have what two genotypes? Okay. I don't know which one it is, so I'm going to put an A here and an A here. And we'll start with this. If there's an A here and an A here, what has to be up here? A here, A here? Okay, B here, B here?
B.
Now for this one, what could be here? B? It could be an O, or it could be what else? An A. So one of the parents has to be AA, or one of the parents could be AB, or they could be AB or BO. Make sense? Flip to the other side. Okay, the children are half AB. This is going to work out basically the same way. I'm going to put AB up top. I can do it. You know what? I'll put AB there and AB here. It doesn't really matter. You keep it the way you have it. In order to have an A here and an A here, what do I have to have here? A. In order to have a B here, what do I have to have here? B. So I'm going to put B here. And the other group of kids was B, but they could be BB or BO, right? Okay, so I'll put B there. And this one's also B, so to have a B here to B here, what has to be here? B. Now, for this one, though, what could we have up here? You could have O or B. So one of the parents definitely has to be BB. The other one has to be what? AB or AO. AO. These are your two different ones. Last one. Okay, one's AB, and I'm just going to tell you this. I'm going to put it in, I'll put it right here. It doesn't really matter where you kind of put it. We'll put one there. So in order to get an A here, I'll say I put an A here. In order to get a B here, what's going to be here? B. All right, so now we know we have, basically we have one B, AB, one A, one B, and one O. Right? So if there's a B here, and there's a B here, what's got to be here? B. If there's an A here, an A here, what's got to be here? A. Now, we know there's one O kid. What's the genotype for O? O. Right? So in order to get the O here and the O here, what has to be here and here? So that means that these guys are AO and... See it? It's pretty cool, huh? No, it's not that hard. You just got to know this. Dominant, recessive, codominant are also there. Now watch. Read along with me again. This is something called a pedigree chart. You will run into these, but they're not that hard to just see if you haven't experienced it before. A pedigree or family chart shows parental crosses and the families that result from each cross over generations. In the following pedigree chart, the females are squares, the males are circles. It really doesn't matter. The colors indicate which blood type each person has. Next to each square, I want you to do this. Identify the genotype for each person, okay? We did this before with the parental generation F1 and F2 when we did the toothpick lab, right? Which color is type A? Dark. Which one's type O? White. Okay, now watch. So here's what you can do. All the white spots, we already know what their genotype is going to be. What is it? Okay, so I'm going to put OO right here. OO here. OO here. OO here. And then an OO here. So now you have to backwards, forwards think this a little bit because the question at the end says, it's kind of messed up, but it is what it is. Below, identify which individual in this family is adopted and why. Okay, so you got to figure out which one of these things doesn't belong, right? All right, I know. Okay, so watch. We said dark is what type of blood? All right, so we know this has at least an A. But watch, if you have kids that are O type blood, they got an O from here and one from here, right? Okay, so watch. So this one is AO or OA. Well, AO is fine. So if these parents are OO and this one's OA and these two are A blood, what type of genotype are these other two kids? Gotta be AO. Gotta be AO. Are we okay so far? Okay, now watch. If this kid right here is OO, what allele has to be in each one of these two parents? You have to have an O in each one. But this one's black, so what's the genotype? This has got to be AO and this one's got to be what? Now, can I have, with these two parents, can I have a kid that is B-type blood right here? What would be the genotype though? It would be BO. Can I have a kid that is A blood? What's the genotype going to be though? Can I have a kid that is AB blood? Yes, I can. Because they can have one of each allele, right? Are we okay so far? Okay. Now using these two parents, can I have a kid that's AB blood?
Yes.
Yes, I can. I can have one allele each. Can I have a kid that is A-type blood? Yeah, what's the genotype? Well, it could be AO or AA, correct? Okay, so we're going to say AA or AO. Can I have a kid that has B-type blood? What's the genotype? BO. Can I have a kid that's OO? Why? There's only one O allele you get from the one parent, you don't get it from the other one. Okay? So watch. Right here where it says below, I want you to put a star next to this. We're going to come back to that later. Justice? Just stretching? Okay. Go to the back page. Same thing. Each one of these boxes, though, only has one possible genotype. So we're going to start off, we're going to go through all the generations. We're going to work our way down. And they have little blanks for you to put in the right answer, but we can just draw it next to here and you can fill it out later when you get a chance. O blood has what genotype? OO. So their kid right here is O, so what's their genotype? So if I have an O parent, an O parent, and I have an A-type blood, what does this parent have to be? Has to be AO. So this one's genotype has to be what? AO. So if this one's AO, and I have a kid that is OO genotype, where did the other O come from? The other parent, right? So we're going to put an O right here. But if I also had a kid from these two parents that had B-type blood, what does this genotype have to be? What does this genotype have to be? BO. Are we okay so far? Now watch. If this one is OO blood, and you had an A blood and a B blood kid come from it, what does this parent have to be? AB. So what do these genotypes have to be? AO and BO. If this one's AO, and you have a kid that has OO genotype, what's one allele that has to be over here? You have to have at least one allele over here. But you have an AB kid, so what does this genotype have to be? Has to be BO. If this is BO, this is AO, this is AB. Does that work out okay? If this one's B blood, what does the genotype have to be? BO. And what does this genotype have to be? Pretty simple, right? A and B are codominant. O is recessive. Okay. Phenotype is the blood type. Genotype is the actual genotype, the gene they have. Okay. Now look on the bottom. It says justification. I want you to put a star next to that. You can shut it off. Brenda, you can shut it off now.